right, here's part 2 of analyzing a quadratic. Just wanted to give you one more example. Maybe you guys already hit a home run on part 1 and you totally understand it, but here's just a second example for you, should you, maybe it helped you a little bit. Okay, so here's part 2. So let's say you're given that, and basically I tell you to analyze it and answer some questions for me. Remember, the first thing is we want to find that y-intercept, and that's going to be 0, 5. And when we go to do the x-intercept, remember that we're looking for the roots, and a lot of times we want to go ahead and just factor that. We're looking for the roots or the zeros. And so I start to try to factor this, and I realize it doesn't factor. And some of you guys are like, well, how did you know that so well? You know, you're just really smart. And I said, well, no, actually what I did was I looked at the discriminant. Okay, so I looked at the discriminant. Remember, the discriminant is b squared minus 4ac. It's what's underneath the radical of the quadratic formula. And so I go ahead and I just plop in all these numbers, and I get 12 squared minus 4, a is 3, and c is 5. And when I multiplied all that out, I got 144 minus, this is 12 times 5, which is 60, and I got 84. And since that's not a perfect square, therefore I know we are out of the factor ballgame. Okay, since if that was a perfect square, then I know it would factor. But since it's not a perfect square, I know that it does not factor. And if this was negative, then I would know that it actually has no x-intercepts. That means the entire graph is either above the y-axis if it's cupped up, or it's below the x-axis if it's cupped down. So it's just a good little trick there. Just kind of look at it and be like, this thing doesn't factor. Let's move on. Since it doesn't factor, we're going to have to go ahead and do some more heavy lifting. And I'm going to choose to use the quadratic formula. So I always like to write it down because it really puts it into my head what I'm doing. And so I get negative b, so that's negative 12 plus or minus the square root of, oh, there's my 84. I can just do that real quick. Do you see how I have that already? So a lot of you guys are like, well, this is a waste of time. No, it's not. It's right there. So this is over 2 times 3. So I'm going to get something that's negative 2 plus or minus the square root of 21 over 3. Now, if you are lost at that stage, like, whoa, what happened there? Just take a second, just pause it and work that out on a piece of scratch paper. Take the extra steps, but for time, I'm going to move forward, okay? Now, one thing I do really want to make sure you understand is that this right here, the pink, okay, that is the line of symmetry, believe it or not. That's the line of symmetry. So this is the line of symmetry right there, negative 2. And I know some of you guys, little sidebar here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I can break that apart. This might blow some of your minds. Depends on what your teachers have taught you in the past. But that right there, do you see how I just separated that out? Divide the 2a into here, divide the 2a into that. That is the line of symmetry. So I can always just pick that apart, and that's that constant value right in front. So that's pretty fancy. So I already know my vertex. I know half of it, so I know this is negative 2. And when I go ahead and find f of negative 2, I'm going to take that and quickly do this. So that is equal to, just so you know, negative 7. So I know I skipped some steps there too, but you can check my math if you'd like. All right, so let's get a quick sketch here. So a quick sketch. I know the vertex is at negative 2, negative 7, so I'm just going to say it's right there, negative 2, negative 7. Oops, I'm off the screen. Sorry about that. Negative 2, negative 7. I also know my y-intercept is up here about 5. And I need to figure out what is happening with my x-intercepts. So one thing that I really want you to make sure you understand is that this right here, I'm at negative 2. This is the line of symmetry at negative 2. And I'm going to zoom in here, but this piece, which I'm going to highlight in green, means that I move, okay, I move left and right the square root of 21 over 3 to find those x-intercepts. So what do I mean by that? I'm going to zoom in here real quick. It means this distance in green and this distance in green are both equal to, so this piece is plus the square root of 21 over 3, and this distance is minus the square root of 21 over 3. That's the distance from -2. So this point right here, that point is -2 plus the square root of 21 over 3. And this point is -2 minus the square root of 21 over 3. So for instance, let's just make it easier for ourselves, okay? If this green line, this little piece right here, instead of this being this nasty number, let's just make it worth 5. Okay, so if that was worth 5, I would have -2, my finger's way down here on the screen, -2 minus 5 more. Or then I'd have -2 plus 5 more. This is that difference. I am moving, let me zoom out of here again. I am moving to the left and to the right that much distance. Okay, so these are our x-intercepts on our screen there. So that's a little visual. So real quick, I'm not going to talk about when is it increasing or decreasing here, okay, because that just uses the vertex and that should be really easy for you. What I do want to show you is that, well, what about if I said, hey, when is f of x greater than 0? So then I'm going to have to go from -infinity, so from -infinity on the x values, all the way down to this point right here, which is going to be -2 minus the square root of 21 over 3. Okay, that's when it's greater than 0. And also then from -2, oops, a little typo there, I don't need a comma, -2 minus the square root of 21 over 3 all the way to infinity. Okay, so let me just put that, if I do that in pink here, when's it greater than, right there and right there. That's why those x-intercepts are so important. So this is the pink answer. And then lastly, let's just say if I wanted to know when is f of x less than or equal to 0, well, that's going to be, let's do that in orange, right there. So that's going to be -2 minus the square root of 21 over 3 all the way to -2. Oops, this should be a plus. Sorry, go back up there. That should be a plus. Great thing, I caught my error right at the end there. There we go. Okay, now I know some of you guys are like, well, why can't we just use decimals? Well, you can to check, but I want exact answers. So those are the exact answers. And we are in pre-calculus now, and so we want exact answers. All right, hopefully I didn't make any mistakes because this is a recording, but I think that's pretty spot on. Hope that helps. All right, and have a great day, guys. Thanks.